deep earthquakes are more common than previously thought. Global study reveals scientists have discovered that earthquakes occurring within Earth's mantle, previously considered impossible or extremely rare, are actually widespread across the globe. A new study published in Science on February 5th details how these deep tremors happen, and where they're most frequent, challenging long-held assumptions about the planet's inner workings. The mystery of mantle earthquakes for decades, geoscientists believed earthquakes were limited to the Earth's brittle crust. The mantle, a semi-molten layer beneath the crust, was thought to deform slowly instead of cracking. However, evidence of quakes originating more than 22 miles, 35 kilometers, below the surface, below the Mohorovičić discontinuity, MOHO, the boundary between the crust and mantle, began to accumulate. Pinpointing these events has been difficult because they're typically too deep to be felt, and the MOHO's depth varies. A new method for detection researchers at Stanford University, led by Simon Klemperer and doctoral student Shiki Wang, developed a novel method for identifying mantle earthquakes. They analyzed shear waves that get trapped either in the crust or the mantle, using these patterns to determine whether an earthquake originated above or below the MOHO. This approach allows for more accurate mapping without needing precise knowledge of crust thickness in each location. Global distribution of deep tremors, the study excluded subduction zones areas where tectonic plates collide and one slides under another, known for deep earthquakes, to focus on continental mantle quakes. Findings revealed widespread activity, a dense band stretching from the Alps to the Himalayas, likely linked to intense mountain-building collisions. A cluster in East Africa, where the continental crust is splitting apart, rifting. Additional earthquakes under the western United States and Baffin Bay, Canada. Some locations, like the Bering Sea, were unexpected, suggesting mantle quakes may be more prevalent than previously imagined. Geologist Vera Schultz-Pelcom, not involved in the study, emphasized the significance of interactive mapping tools for further analysis. Why this matters: the discovery of widespread mantle earthquakes has major implications. It forces a reevaluation of how the mantle behaves under stress and how energy is released within the Earth's interior. Understanding these deep tremors could refine models of plate tectonics, mantle convection, and even earthquake hazard assessment. We believe this firmly demonstrates that there are earthquakes below the MOHO in very many regions of the world. Klemperer stated, suggesting this phenomenon may be ubiquitous. The new detection method promises to enable more detailed studies of individual mantle quakes, potentially revealing the underlying mechanisms driving them. This breakthrough provides a crucial tool for geoscientists seeking to unravel the mysteries hidden deep within our planet.